Could China's new energy technology be considered the fifth great invention of China? Many people ask me this question, especially since the pace of dual carbon development in Europe and America has slowed down. So, why is China still pushing so hard to develop new energy? Recently, I heard a brilliant response. Today, China's new energy technology will undoubtedly become China's fifth great invention, bringing new prosperity to the world, a shared prosperity for the destiny of humanity. When you think about it, it really makes sense. Look, China's advancements in photovoltaic, wind power, and energy storage technologies are enabling more and more people around the world to access clean and affordable energy, transforming their lives and even their destinies. In the deserts of Saudi Arabia, Chinese companies are building the world's largest single photovoltaic power station. Who could have imagined that this once barren land would one day produce endless clean energy and become a land of wealth? In remote villages in Laos, wind turbines from China have ended the history of unreliable electricity for local residents, lighting up new hope for their lives. And in Ulaanbaatar, the capital of Mongolia, China's energy storage technology ensures that residents still have sufficient power even in extreme cold of minus 45 degrees Celsius. Perhaps the nights in Ulaanbaatar will no longer suffer from power shortages during severe cold spells. However, in my opinion, this prosperity is still in its early stages. Why do I say that? Because there's still a major challenge with new energy. Its proportion in the power system cannot be too high. Achieving 100% of electricity from new energy is even more unattainable. On one hand, the instability of wind and solar power generation is well known. If the proportion is too high, the entire power supply network becomes unstable. But beyond that, there's another critical reason. New energy power stations cannot provide voltage and frequency support to the grid like traditional thermal or hydropower plants. Thermal and hydropower plants use synchronous generators to provide voltage and frequency support to the grid. What's a synchronous generator? Let's not dive too deep into that for now. Just remember this. It's a rotating machine primarily used in thermal and hydropower generation. The process of new energy generation is completely different. As a result, when the proportion of new energy in the power system increases, the proportion of synchronous generators decreases, reducing the support for voltage and frequency and increasing the risk of grid instability. Moreover, with current technology, the voltage and frequency of new energy grid connection follow the grid. In other words, if the grid's voltage is high, it follows high. If the grid's voltage is low, it follows low. This means that thermal or hydropower must exist in the grid to establish the voltage and frequency first, before new energy can feed power into the grid. If we compare thermal power plants to powered train engines, then new energy power stations are like unpowered train cars. They need the engine to pull them along. In other words, the vision of a grid powered 100% by wind and solar energy is still quite challenging to achieve. So, what's the solution? Some have proposed an idea. Let new energy power stations mimic the behavior of synchronous generators, allowing their grid-connected voltage and frequency to be autonomously controlled. This would essentially turn new energy power stations into train engines. This idea later evolved into a technology called grid-forming technology, also known as the ultimate technology for high-proportion new energy utilization. Grid-forming technology can be applied to the grid connection of photovoltaic, wind power, and energy storage power stations. Currently, however, its application is most widespread in energy storage systems. This is because energy storage can output power on demand, making it the perfect carrier for grid-forming technology. How is it achieved? Primarily through power electronics and control algorithms. While it might sound simple when I explain it, actually implementing it is far from easy. At present, very few companies truly master this technology, and its application is even rarer. But recently, I've learned that China has made significant breakthroughs in grid-forming technology. A Chinese energy storage company has developed a new generation of system-level grid-forming technology, also known as Gengrid generative grid technology. Some time ago, After undergoing over 6 months of rigorous testing with thousands of performance evaluations at the Ordo's real machine validation platform, it successfully achieved full scenario and full condition grid forming. This means the technology passed tests in weak grids, microgrids, black start scenarios, and more. Such comprehensive testing is a world first, demonstrating that grid-forming technology has universal applicability. Moving forward, it can be scaled up and promoted as needed. In fact, China has already begun applying grid-forming technology. In Chifeng, Inner Mongolia, the world's largest zero-carbon hydrogen ammonia project is underway. This project uses 100% wind and solar power for hydrogen production and has been running stably for nearly a year. The green ammonia produced has already been sold to Europe. How is 100% green electricity hydrogen production possible? It's all thanks to this grid-forming technology. From this 100% green electricity hydrogen project, I not only see the future of grid-forming technology, but also glimpse an even greater prosperity ahead. Right now, the world is facing a new technological revolution. We're seeing groundbreaking advancements in artificial intelligence, autonomous driving, and low-altitude flight technologies. Just imagine the impact these technologies will have on the world once they mature. But to develop these new technologies, we're going to need a tremendous amount of energy. In the future, humanity's energy demand could grow by multiples, tens, or even hundreds of times. So, where will all this energy come from? I believe that China's continuous progress in energy technology, new photovoltaic and wind power technologies, along with grid-forming technology, holds the key to unlocking this endless supply of energy. So, don't you think the greater prosperity brought by China's fifth great invention is still waiting just around the corner?